saying here is two values are said to be in inverse proportion when one value decreases at the same rate that the other decreases. So one is increasing, one is decreasing. Um, I will look at an example to illustrate this. So if we look at some typical real life situation, we can be able to discuss this in detail. This is an example. If Tom takes 10 minutes to cover the distance at 120 kilometers per hour, how long will it take him to complete the same journey if he's traveling at 100 kilometers per hour, 80 kilometers per hour, and so on and so forth? So first thing is we need to establish what formula are we going to use here. Of course, we can see we have minutes, which is time, and we have speed. Now, if you remember from year 8, you had looked at this relationship between speed, distance, and time. And speed is equals to distance over time. This triangle is important. It can help you to remember that. So if you want distance, it will be speed times time, which will be equal to, now if you look at our question here, we have the speed, which is 120 kilometers per hour. We have the time as well, which is 10 minutes. We have to convert that to hours, which will be 10 over 60. And if you work that out, if you just plug this in your calculator, you'll be able to get 20 kilometers. And remember, in this situation here, Tom is traveling the same journey. Okay, so same distance is covered. But he's traveling at different speeds. What we want to look at is we want to find the relationship between speed and time. So let's start by working out the times for these speeds that we have here. So for the first part, I'll start time will be equal to, we know of course time is distance over speed. Okay, so you're going to use that formula on the left. So time will be distance, which is the same all through. 20 over speed is 100. So if you work that out on your calculator, you'll get 0.2 hours. Remember here we have our distance in kilometers and speed in 100 kilometers per hour, so our time is in hours. We can convert that to minutes by multiplying it by 60. So if we multiply this by 60, we will get our time in minutes, which will be 12 minutes. And you're going to do the same thing for all these questions from A to D. So for B, we'll have time will be equal to 20 over 80, which is equal to 0.25 hours. You can check this on your calculator, multiply that by 60, and then you'll find that that is equal to 15 minutes. Here again, you have 20 over 60, which will be, you'll get a decimal, but write it as a fraction, a third hours, so a third of an hour. Multiply that by 60, what you'll end up with is 20 minutes. Time again here, it will be 20 over 50, which is equal to 0.4 hour. Multiply by 60, That will be 24 minutes. And then the last one. So for the last one, here we'll have time will be equal to 20 over 40, which is equal to 0.5. It's just a half an hour. 0.5 hour multiplied by 60, we get that is 30 minutes. So we have a relationship here, and what we want is for us to be able to see this clearly. Maybe let's graph it, maybe let's put it in a graph, and that will give us an idea of what the relationship between these quantities are. So I'm going to graph this. Now what I'm going to do is, on the y-axis, that will be represented by the speed, kilometers per hour. On the x-axis, I'm going to represent my time in minutes. So 5, 10, 15, 20, 25, 30. Then vertically, I'll have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, and 120. Okay, just trying to fit this on this graph. So from the information that we have on the previous page, it takes Tom 10 minutes to cover 120 kilometers. So that means that 10 minutes, 120, somewhere there. And then 12 minutes, 100. So 12 is around there. 100, so somewhere there. And then we have 15, 80 kilometers. Somewhere there. And then 20, 60. Somewhere there. And then we have 24, 50. Somewhere there. And then we have 40, 30, 40 kilometers per hour, so somewhere there. So if we draw out, this is just a sketch. So our graph will look something like, it's not exactly, yeah, it's something like that. But what we can see here is actually, if I correct, I think 15 will be somewhere here. 15 will be somewhere here. So that our graph will be something like that. Yeah, that's much better. And you can see here that as one quantity increases, the other one is decreasing, which makes sense. And that's why we call it inverse proportion. So we can draw some conclusions based on what we have calculated from this question. So this is one of the things that we can conclude from the results that we have here. And there are lots of things that you can actually write from the results that we have here. But of course, what we are saying here is there's a relationship between speed and time. Here's another example. If 8 people can pick the apples from the trees in 6 days, how long will it take 12 people to do the same job? So what we can do here is we need to find a way of organizing this information. And we can start off this way. We can say that 8 people will take 6 days, which means one person will take more time, which will be 8 times 6, which is 48 days. If they're going to work at the same rate. So, which means that 12 people, if they're working at the same rate, they'll share this work among themselves. So they're going to take less number of days, which will be 48 divided by 12. So 12 people will take 4 days. Here's another example. A teacher shares candies among 8 students so that they get 6 each. How many candies will they receive had there been 12 students? So what we have here is that 8 students get 6 candies each. So maybe we can ask ourselves, how many candies are really available? How many candies did the teacher have with him or her? So total number of candies will be the 8 students, each student has 6 each, so that will mean 8 times 6, which will be 48 candies. So how many candies will they receive had there been 12 students? So that means if we had 12 students, then they would have to share the 48 candies among themselves. So 12 students will be 48 divided by 12, which will be 4 each.